Hey Sam.
Hi,
Hi, how are you?
I'm good. Thanks for asking. I hope that the event is going well.
It is, and yeah, we're excited about your session. And yeah, I was just starting to say that you're gonna talk about one of the oldest challenges in the web, is that sometimes we need to create offline experience as well. And
Yeah,
then I know in the beginning it was difficult. You need to do a lot of things, but now we have various tools and technologies that help. So this
yeah,
is the case today, right?
that's right.
Um, all right. So then, yeah, you have the floor,
All right.
and yeah, we're gonna catch back after your talk to discuss a bit more.
Okay. Is my screen visible?
Yes.
Okay, good. So, hi everybody. Does this game look familiar to you? It's the game that you see when you use Chrome as your default browser. So you might have played it before. And it's the screen that will get presented to you as soon as you're offline. But no worries, because today we're going to talk about some techniques that will enable offline capabilities for our applications. So actually, we're going to talk about ways that we can remove this screen for your users and for your applications. And that means that today we will be creating powerful offline experiences with Workbox. And this session was postponed a few times. I don't have to tell you why, but I'm very happy that I can finally deliver this talk today. First of all, a big thank you to the team of Codecamp for the invitation. And I have to say that the onboarding process for me as a speaker was very smooth, and it seems like the event is going very nice. So please join me in thanking them for organizing this event today. And from my side, I hope you will be learning something new today. Who am I? My name is Sam, and I'm a freelance software engineer. I'm also the co-organizer of the Belgian Angular conference called NGBE and the Angular Belgium Meetup group. And today I'm happy to serve the Angular community as a Google developers expert. If you want to know more about me or read my articles, feel free to check my website. So, offline web applications. Offline web applications are actually not that new. They have been around for a while. If you would ask me how long exactly, I'm not sure, because I only started coding websites in 2006, and apparently offline web applications were already a thing at that time. So the evolution of a technology called user data to flash cookies and gears from Google, all technologies from before my time, as I said, led to storage APIs that are now part of the enablers of all offline technologies. And Google Gears was, for example, popular when I started building, but I never used it because at that time I was just getting handy with basic HTML, CSS, and JavaScript. So I was not even considering offline stuff yet. But probably the most well-known example of Google Gears back then was the first offline Gmail application. And then also Firefox OS. They also had some ideas about going offline with web applications, but those projects were shut down in 2015, I think. So eventually Gears was shut down as well in 2011 because of course, the evolution of offline capabilities in the browser. It was simply not needed anymore. And that was because we had AppCache. And AppCache was the first full offline framework that was native to the browser. And basically, AppCache is just a browser API. It uses a manifest file, and the manifest file is just a simple text file listing all resources that are relevant to the offline usage of the application. And this manifest is loaded via the manifest attribute on the HTML tag. If we wanted to update the cache, that was simply updating the manifest file. And that happened by means of a simple byte comparison. So for example, when changing the version or the date in the first command line. The AppCache manifest allowed us to list all the resources that needed to be cached and made available offline. And there was somewhat support for more advanced configurations, like, for example, network first strategies and default files to fall back to. So what are the strong and weak points of AppCache? The first strong point is that AppCache can be very useful even when you're online. It gives you an extra layer of cache control next to typical disk cache. And using AppCache, you can avoid hitting static assets on your server when the visitor is coming back to your application. And its configuration is done via a very simple text config file, the one that we have seen in the previous slide. This is somewhat an advantage because configuration is easy. On the other hand, the config file does not give you much control. So using more complex configuration or programmatic logic with, for example, let's say regular expressions is hard, or it's actually not even possible. And AppCache is also not very forgiving. So that means it's not very foolproof or fail-safe. If any of the resources listed, for example, in the file from before, and they're not available to cache, the complete offline configuration will fail. So let's conclude with saying that the AppCache story. Let's conclude the AppCache story by saying that the intentions were good. And if you had some automated processes, we could minimize the human failure to allow us to build stable offline web applications. But AppCache quickly became deprecated because, as usual, developers want more and better control. So the concept of a service worker was born. And basically, a service worker is just a JavaScript script running in the browser, but in the background. And it's registered for a specific application and behaves as a programmable network proxy. More on those details later. So yeah, programmable network proxy. So as I said, a service worker is basically just a script or similar to a JavaScript worker running in the background. The only difference from a web worker, well, a main difference from a web worker is that it's installed in the browser, so standalone from the web application. And that also means that it has its own lifecycle, independent from the lifecycle from the application. Registering a service worker, fairly easy. This is the basic code that we need to load our service worker in our application. We first have to check if the service worker support is available in the browser. And if that is the case, we can continue by first waiting for all resources to load before we register the service worker. Why do we wait for all the resources to load? Because the service worker could already interfere with the initial load. And this could potentially destroy the initial performance of your application. And there are some other things to consider for service workers. A service worker requires HTTPS, but these days most HTML5 APIs do. Other examples are, for example, notifications API, geolocation API, the media stream API. Practically all HTML5 APIs require HTTPS these days. Another important part is that service workers do not have access to the DOM. So we cannot directly access elements of the page that the service worker is controlling. But if we really want to do that, we can send commands from the service worker to the application. And communication with the application is possible via the post message API. Another important part is that there is no reliable global state. What does that mean? There is no, to be more precise, there is no reliable global state in the runtime scope of the script of the service worker. So that's basically because the service worker starts and restarts independently from your application. You cannot control that. It's the browser or the operating system that is in charge of the lifetime and the life cycle of the service worker. Fourth important part is that service workers can only access async APIs. So a service worker has no access to, for example, local or session storage. Why? Because local storage is a sync API. On the other hand, we do have access to other storage APIs, like, for example, IndexedDB. Why? Because that is an async API. So actually, the main capability of a service worker is that it acts as a programmable network proxy. In simple words, that means that a service worker just intercepts all network requests done by the application. And it also intercepts all responses coming back from the network for those requests. So you can already imagine different scenarios here. But just think about it. The service worker will be the main enabler of our offline functionality. Why? Because it can modify requests and responses while intercepting them. And it can cache responses for later use. So let's visualize a bit how this works. So a typical web application does a request to the network, and in the best case, the server returns a response. There's no big deal or rocket science here. This is basic. But when we add a service worker in between the web application and the network, we can cache our resources, and then the behavior changes completely. So first, the application requests a resource on the network, and the service worker intercepts it and checks if the response for this request was already cached. So the first time it's not, so the service worker forwards the request to the network. Now the server or the network returns the response to the service worker, and in parallel, the service worker adds the response to the cache and forwards the response to the original requester, which is the application. So if we continue in the usage of our application, on any subsequent request to the same resource from before, the following flow will happen. The browser requests a resource and the service worker proxies this request. But now the service worker checks the cache and sees that there is already a response cached for this request. So the cached response is returned to the service worker, which in its turn uses this response to reply to the request. And this is the basic idea of caching for offline usage, for example, using service workers. And this behavior, what you see here, is highly configurable, but this gives you the basic idea. And this basic caching behavior is called the cache-first strategy. But of course, there are many other strategies available. So how can we enable all of this functionality? Because you do not get this for free. You need to program it. And coding this functionality by hand can be very challenging. So the code that we see here is a very basic implementation of a cache-first strategy using just normal JavaScript without any framework. But if we consider a framework, this could result in much less code, as you can see. So introducing Workbox. What is Workbox? Well, Workbox is basically a set of libraries and node modules that are maintained by Google. So Workbox is a framework by Google. It's also a tool to facilitate, well, to get more use out of service workers. It gives you more enhanced and more clear APIs to fully enable the power of progressive web apps. It also has TypeScript support since version 5. And as I already said, it gives you all the libraries that you need. So in fact, Workbox, or just service workers, but Workbox gives you the tools to make our application fully available offline. And fully available offline, of course, needs to be taken lightly with a grain of salt, of course, because we cannot go completely offline. And that means that we need to do some synchronization and some updating as soon as the connection is back up and running again. And of course, you need to have been online at least once, because if you're not online, you cannot load the functionality, of course. So the two core concepts of Workbox are pre-caching and request handling. Let's explore those two concepts into detail. So the first core concept of Workbox is called pre-cache and route, to be exact. And the idea here is that we collect and list all the available static assets of our application. And we want to make those available to the user, so to the browser, in fact, without the need to get it from the server again if we already have them. So you could think about the basic collection of your available static assets of your application as the app shell of your application. So we're going to make the app shell available offline. So yeah, what we see here is a placeholder. So the self.wb manifest is a placeholder where the tools of Workbox will inject that list for you. So how can we use this pre-caching and route? We can use CLI of Workbox. We can use just normal node scripts or even Webpack plugins. But before we can get this to work, we need to configure our Workbox setup by providing a configuration file. And the base of the configuration file is very easy. So we specify where our assets are loaded by, for example, specifying the directory where some of the glob patterns should be applied. And of course, the glob patterns to apply. And these patterns will list up all the relevant files for you that define the app shell of your application. We need to specify the source file of our service worker and where the result of the Workbox process should be outputted. So an important thing here to remember is that this process should, of course, run after all your other build processes, because you want to include all the static assets into the pre-caching. Yeah, so the service worker source is optional because we can also use Workbox to generate the service worker for us. I will show you that later. So as I mentioned, several options for using the two basic tools of Workbox. And the first one is the generate service worker. And generate service worker does what it promises. So it generates a complete new service worker for you, completely based on the Workbox configuration that we provided. And inject manifest uses an existing service worker and injects only the list of static assets into the in your own source of the service worker. So it uses the self.wb manifest to replace that code with a list of assets. So in the end, both tools inject those assets into the service worker. And using these two options with the CLI is as simple as what you see here. So we just call the command mentioned above. It's just Workbox generate SW, and we provide the Workbox configuration file. In this case, Workbox will generate a new service worker file automatically for you based on the Workbox configuration. So yeah, I'm not going to say this again. The pre-cache and route assets are just listed and automatically injected. What you see here is also the revision hash. So the revision hash identifies the version of the specific asset. And the same is true for the inject manifest command. But for this command, we need to make sure that we update our Workbox configuration file by providing a source of our service worker. So same result as using generate service worker. Exact same thing can be achieved using node scripts, as you can see here. So it's just programmatically calling the same commands, and they output exactly the same. So yeah, we use the same configuration for both generate service worker and inject manifest. And you can install those node tools by installing Workbox build. Same is true for Webpack. Acts the same way. We just add the generate service worker and inject manifest Webpack plugins to our plugins file for Webpack. So in all of the cases, we get the same result. Our static resources, the one that we choose by providing the correct glob patterns, are injected based on the Workbox configuration. And as I already mentioned, we get a revision to the version of the file, and that complete list of static assets should normally define the app shell of your application. So I would say just prefer your favorite method find out what's the most applicable for your project. So let's recap both functionalities, generate service worker and inject manifest. When should you use one or the other? You should use generate service worker when you just want to pre-cache files and you have a very simple runtime configuration. For example, the configuration allows you to define routes and strategies. But you should not use this if you want to use other service workers. For example, service worker features, like for example, web push, or you want to import additional scripts or add additional logic. Why? Because generate service worker will always override your existing service worker. So if you make an update after the generation process, that will get lost as soon as you run the command again. Inject manifest, when should you use that one? So if you just want more control over your service worker and you still want to pre-cache files, but more control means that you can address more complex needs in terms of routing for your static assets. And you want to code other functionalities into your service worker, like for example, the one that I already mentioned, web push. Don't use inject manifest if you want the easiest path to adding a service worker to your site, because that is the easiest path to generating a service worker is of course generate service worker. So is it all clear? I hope so. If not, you can always ask questions in the QA after the talk. So the second core concept of Workbox is route or request handling. And we use this to program our service worker by instructing it which requests should be intercepted, and more specifically, how we should handle those requests. And by doing that, we start with the first parameter, which is the matcher. And a matcher can be basically anything, a literal match, a regular expression, or a function, but it should just evaluate to true or false, meaning that if it evaluates to true, then this request should be handled by that handler. And the second parameter is that handler. So the handler basically defines the strategy to use for a matching request. So Workbox comes with a well-defined list of caching strategies, like for example, the one that I showed in the beginning, the caching first strategy. But you also have wait, I'm going too fast. Yeah, so there are different caching strategies. The network first. And the network first strategy will first try to visit the network for that request. And if it's not available, then it tries to look in the cache for a corresponding response. The cache first strategy will first try to hit the cache. And if it's not available, it will try to visit the network for a new response. The network only will only accept responses from the network, so it will completely ignore the cache. On the other hand, cache only will completely ignore the network, but only accept responses from the cache. And there's one special one, stale while revalidate, and this strategy will return the response from the cache, but update the cache afterwards if the network is available. So the user will first get the cached version, and in the background, the new version is put in the cache. Then there are still route handling plugins that we can attach to the route. And those get executed with a matching request. Like for example, background sync, broadcast update, cacheable response, expiration. They all have their own goal, but for example, background sync will do some background synchronization of that data as soon as the response is there. And you can also, for example, attach a broadcast. So as soon as something new is cached for this request, that we can notify every listener, for example, in the application to, for example, do some functionality like there's a new version available of the application. All of these things are programmable. So these are just the out-of-the-box solutions available by Workbox. All of this can be programmed by yourself. So if you want something very exotic, if you want to do your own behavior, you can program this. So very important to keep in mind is that we are caching data, but of course browsers have limited storage capacity. So we should always keep in mind that we should use the storage capacity wisely and not cache too much. We should also try to invalidate the cache if something is not needed anymore. If something is not relevant anymore, we should remove it from the cache. And why is this so important? Because in general, laptops or PCs, they are not an issue. They have a lot of available disk space, they have a lot of available memory, but phones and tablets might not always be the case. A good example is from a project that I did. Employees got a tablet from the employer, but the tablet had to be used to install a progressive web app. But the tablet was also used personally, and they downloaded movies and taken pictures with it. So the storage was already full. They had only like 10 megabytes available. So you will have to do it with 10 megabytes in that case. That's not a lot. So always need to check your own use case and validate it, and check the devices of your audience. So Workbox has many use cases, and many of them will be specific to your application. But there are some common recipes or scenarios that are very likely to come back in many applications. For example, the default path handling for single-page applications. So when you're developing a SPA, using any framework, it doesn't matter, Angular, Vue, or React, you typically only have one HTML page. And that HTML index.html file is the response for any request that you do to your server. So if you go to the home page, you get the index.html. If you go to /about, you get the index.html file. So this index.html file is loaded for all your routes. And in all cases, your web server should be capable of serving that file for all your routes. So you're doing configuration of the server. But when we're offline, we are not hitting the server. This is a potential problem. We are missing a configuration that will always return the index.html for each navigation request. But the good part is that a service worker acts as a network proxy. It's a programmable network proxy. So in fact, you can do the kind of the same configuration that you have on your server. You could do this in your service worker. So in case that you're offline, or you already have the index.html cached in your cache, the service worker will return the cached index.html page for all route navigations. Let's illustrate this to be sure that we are on the same page. So in the most basic example, the navigation request acts the same way as requesting a resource from the network. So the server returns the index.html for any navigation request, in this case, /news/123. When we have a service worker installed, this acts somewhat differently. The browser makes a navigation request, so the same page, news123, but the service worker intercepts this navigation request and proxies the request to the network. The service worker receives the index.html file from the server and adds it to the cache. And in parallel, the service worker returns the requested page to the browser, and all is good. On any new navigation request, for example, to a different page, in this case, the About Us page, the service worker will again intercept that navigation request. But now it will return the cached index.html. So the server is not being used anymore in this case. So it becomes obsolete for this version of the application, for this user. And this is the functionality that makes our application available offline, but it also gives you a benefit when you're online, because you're not hitting the server. So the code to achieve this can be written in different forms. Again, using pure JavaScript, we can start leveraging Workbox, using caching strategies and runtime caching. But of course, Workbox framework gives you this capability out of the box, because this is a very common case, and Workbox gives you like a new navigation, the navigation route that you can just instantiate, and then everything works fine. So less coding because of the framework. Another concept known to people who are building mobile applications is, or perhaps not, is the concept of Li-Fi. And what does that mean? So let me tell you a short story. So let's imagine that a user is using your progressive web, your offline application on its mobile phone, and it's basically a application loading news data. So whenever the user is online, he gets that data. But whenever he goes into a tunnel, or whenever he has a bad connection, it could be that the request for the news data when refreshing the page takes like 10 seconds. But I need to make sure that I don't mix concepts here. So it takes 10 seconds, and in that case, it takes too long, because imagine that you're going on Google and you open a page and it takes 10 seconds to load. You probably go looking for something else. So in that case, it's better to return the previously cached version of the news. And in the meanwhile, in the background, we keep waiting for the available data. So as soon as that network request comes in with a response, after 10 seconds, we update the cache. So the next time that the user loads this, we can show the new version of the data. But that's not really Li-Fi. I mixed that up a little bit. Li-Fi means basically that the browser believes that you have an internet connection. And when is that possible? For example, your computer is connected to the Wi-Fi, but the Wi-Fi is not connected to the internet. And in this case, the browser believes that you're connected to the internet. So basically, Wi-Fi means Li-Fi because you're not really connected. You just have a connection to the local network. So I think I diverged a little bit from the topic, but it's basically Workbox comes with a plugin that gives you like the expiration plugin that tells the service worker that any request that takes longer than a given amount of seconds should continue in the background, but meanwhile return the available cache, if it's there, to the user. And I think I can best illustrate this with another diagram. So how does this work in detail? So imagine that we have already something in the cache for our request, for example, the news data, perhaps from a previous session, whatever, doesn't matter. So when we request again the news data, for some reason, that request is delayed with 10 seconds. We might have a bad connection. We might be in a tunnel for 5 seconds, and we come out of the tunnel after that. So the request is delayed. So let's assume that our Workbox config is set to timeout after 5 seconds. So if there is a cache available, we return that cache after 5 seconds. But the original request keeps running in the background. So after 10 seconds, when it's resolved, the response is used to update the cache. After a few minutes of reading, we try to reload the news overview again, but the same thing happens. The response is delayed. This time, so it also times out, but this time the user gets back the updated resource, because in the background, the cache got updated. So we get back version 2. And again, same thing is true in the background. The other request will keep going, and as soon as that resolves, it will update the cache. So another main capability of Workbox is enabling offline Google Analytics. And what you see here is the basic setup. We just import initialize from Workbox Google Analytics, and we initialize it. So it gives us support out of the box. So if you're tracking statistics in your web application and you make it available offline, you don't want to miss those statistics from the interactions. So how does this work? Workbox just caches the data. It caches the interactions. And as soon as you come online again, it will start hitting the server and sending those interactions again. This gives you a new metric. You can know which actions were performed when offline. So when you want to know that, you can use a custom dimension that will get sent with the interaction when that interaction happened offline. And that so the configuration of that custom dimension, it's a Google Analytics thing. You can find the documentation on the Workbox website, and it's pretty straightforward. So we give it the custom dimension with the name network status, and we set its scope to hit. I will show you that in the demo. And as an optional last step, we could set a default value for this custom dimension to offline or online, so that we can make a clear distinction between which visits to which pages happened online and offline. For example, in this case, what you see here, 3 visits to the About page happened when online and 1 was offline. Of course, something that we see typically from applications these days is that we can update to a new version of the application. And Workbox, of course, allows us to do that. Checking for a new version can be done using different approaches. We can start checking for a new version as soon as we open or when we close and reopen the application. We can do this by letting the user click on a button. We can do this, for example, when changing tabs, so when the application becomes visible again. Or we can set up an interval, let's say every 10 minutes or every day or whatever. We check if there's a new application available. So I have 5 more minutes for a short demo. Bear with me. I will try to show it. So normally you should see my Workbox demo application. Let me know if that's not the case, Dan. So this is a very basic setup. I will start from scratch, load the application. So one of the main functionalities, of course, is that the application should work offline. So let me check that. It's offline. And we can see that the application responds to that by showing that the user at the application is offline. But the most important part, of course, is that when we refresh, the application still works. So updating, as you can see on the homepage, it's shown again, different ways of updating. And for that, I will make a very basic change to the application. Update something. Yeah, you don't see this now, but I'm updating the basic application to do a console log, then building it and deploying it. So I'm now deploying a new version of the application. And as I said, there are different ways. We can click the button to see if there's a new version, but we can also change tabs. So as you can see in the console, it's trying to update, but there's no version available because it's not deployed yet. I'll go back to the tab and I will switch back as soon as the new version is deployed. That should not take more than 10 seconds. Almost there. Uploading. Okay. So Firebase tells me that the deploy is complete. So now normally, fingers crossed, get back. Let's try again. Ah, yeah, of course, I'm offline. I'll go online again. I'll switch again. I'll check for an update. Still offline. That's weird. Yeah, I should have made an offer to the demo gods. Try again, because I don't think I made a change, a proper change. SCSS, styles, background of the body, background is pink. Application is building, bear with me, please. Uploading. I'll have to skip a few parts of the demo because I'm running out of time. So let's try again. Check for an update. So it got updated. Yeah, so there's a new version available. We update the application and the application is updated. Okay, I'm going to continue to the next demo, the one about the navigation request that I explained to you. So basically when we're offline, let me hide the mobile view. Well, what you can see here is that we navigate. So if you go to the about page, the URL changes. But if we're offline, that server functionality should also work in the browser. So when we refresh, Workbox kicks in, and for the navigation request about, we get back the index.html. Then the part about Google Analytics offline, you've already seen this. So whenever we navigate, we're trying to send, Google Analytics tries to send the events to the server, but it's not working. So it collects them, it keeps them in memory, and as soon as we go online, it resends them, so they get back sent back to the server. Okay, I'm going to skip the demo. I'm going to go back to the presentation. So you might have already heard about progressive web apps. They require a service worker. We have that now. But to make it a progressive web app, we need to add something more, and that's the manifest.json. And what's the manifest.json? Basically, it contains metadata for your application, like icons, the orientation, the color of the theme, stuff like that. If you want to check more details about that, I will share the presentation afterwards, and you can check into details. Loading the manifest.json, basically done by providing a link rel in the HTML head, and that's it. From that point on, you have a progressive web app. So to conclude, offline functionality has grown over the years, and we went from browser plugins to native APIs. So before we needed extra libraries, but now we can use APIs from the browser. And we can use, that means that we can use service workers to get our application working offline. If we just add a manifest, we get a progressive web app. And Workbox basically by Google is a tool that allows you to generate or extend your service workers. Workbox gives you pre-caching capabilities that allow you to use the app shell pattern and runtime caching. Workbox comes out of the box with support for very common and custom advanced scenario handling, like for example, offline Google Analytics, detecting Wi-Fi situations, which sadly I could not demo because of time, and for example, intercepting and modifying requests at runtime. That allows you to show your users a functionality like there's a new version available. And of course, many, many more, depending on your use case. If you want to do some more reading, last year I've written several articles about using offline capabilities by implementing offline capabilities by using Workbox. And this great guy, Sebastian, written a blog post about building service workers with Workbox using TypeScript. And the example repository that I've shown, the code is available in a repository that you can find here. Of course, the Workbox documentation. Special thanks to Jeff Posnick from the Google Web DevRel team for validating the slides. And thank you for your attention. Feel free to contact me directly. And I hope there are some questions because I was not able to do the demo properly. So let me answer your questions.
Thank you, Sam. Yeah, it was very interesting presentation.
Yeah, a little bit sad about the demo, but yeah,
we know how
that happens.
The demo got. Yeah, it happens. No worries. We started this by mentioning that creating offline experience is a long time challenge, but then it also leads me back to the other thing, which is what are the most difficult two things in computer science? Remember that saying? So we have naming conventions, caching validation, and of course, off by one error. But talking about caching invalidation, what would you say are the good strategies to do this?
So what are the good strategies for caching invalidation? Well, Workbox will clean up for you. That's a good part. If a version of a file is not needed anymore, it will be removed from the cache. So Workbox gives this out of the box for you by those revisions. It builds a revision hash based on the content of the file and adds that metadata to the IndexedDB where all those files are maintained. So whenever you update a new version, Workbox checks if that cache needs to be maintained, and if it's not, it invalidates it.
And what if there are moments, for instance, if you trigger or release an update of your application and then you want certain items to be invalidated?
If you want to do that, you can programmatically do that by adding codes to your service worker. If you know which files to target. So if you know what cache to invalidate, you can write a small script that will remove the cache for you. And there are fallback scenarios. For example, there are cases where you cannot recover from, for example, a malicious Workbox configuration. Something went wrong, for example. Then you can just deploy a service worker, very basic script that will just remove everything. That will remove all the cache.
All right, and we have a couple of questions. Yeah, they all revolve around caching. One is you're mentioning various strategies like cache first or network, and there was one network only. Yeah. What is the purpose of this study? It sounds a bit strange at first, I have to admit as well.
Yeah, I have not used it myself, so. Well, those strategies can be used in different ways. If you have some logic, depending on a very specific situation, for example, if you're loading news data, but at some point in time, for example, at between 4 and 5, you don't want the caching to work. You just check the date and time and you say, okay, now the strategy for this request should be network only. But yeah, that's the best example I can think about.
It makes sense. And our attendee also, they asked for an example, but then, for instance, maybe the next question might help. can we use different strategies for different types of assets?
Yes, yeah. So we had the pattern matcher. So if we, let's say, if the browser requests a CSS file, we can attach the network first strategy or the network only strategy. If we check if the matcher of, only evaluates to true for a JavaScript file, we use the cache only strategy. So this is whatever you want. The matcher function, you implement whatever you want. You just, the input of the matcher is the request, is the URL of the request. So if you have specific logic for a specific request, you can attach a very specific scenario or strategy for that.
Right, and it makes sense because yeah, there might be assets for which you want to use the network only strategy.
Yeah, I don't know. I haven't seen any yet, but there could be cases. Yeah, of course. Yeah.
Just in case. All right, Sam. Well, it was great having you with us. And also thank you for the kind words in the beginning about organizing everything. Yeah, it was your first time at Codecamp. Hope you enjoy it.
Yes,
Enjoyed
I
it.
did.
But then, yeah, we hope to do it again in the coming conferences.
Yes. So good luck with the last talk. Thank you very much for the invitation. Hope to see you soon.
Thank you as well, Sam.